Welcome back. In this section, we're going to see an example of a two-tailed test. So jumping right in, what do you think is more important, to protect the right of Americans to own guns or to control gun ownership? When asked this question, 46% of all Americans said protecting the right to own guns was more important. The Pew Research Center surveyed 1,267 randomly selected Americans with at least a bachelor's degree and found that 559 believed that protecting the right to own guns is more important. Does this result suggest that Americans with at least a bachelor's degree feel differently than the general American population regarding gun control? We'll use the alpha equals 0.1 level of significance. Okay, so what are our hypotheses? Well, so H naught and H1. So our null hypothesis is the one that claims that the proportion is will be 0.46. In other words, that the proportion of people with bachelor's degrees is that feel a certain way is the same as the proportion in the general American population that feel a certain way. The alternative hypothesis, the one we're investigating, is that the proportion is different. So let's see. We have a point estimate of the proportion. That's our x over n. So in the sample, there were 559 Americans that believed one way, and that's out of a sample of 1,267. If you do that on a calculator, you'll get 0.441. So the proportion in the sample was 0.441. We're investigating whether or not that's different than the proportion in the general American population, 0.46. Well, I didn't say that quite right. Obviously, 0.441 is different than 0.46. They're not the same number. But we're investigating whether the proportion of people in the proportion of people with bachelor's degrees is different from the proportion for the general population. Here's our point estimate for the proportion of people with bachelor's degrees. Okay, so what do we need to do next? Well, that the proportion, the sampling distribution of the proportion is a normal or approximately normal distribution. So at this point, we just need to convert to the standard normal so that we can look stuff up in our table. Okay, so let's see. Well, to do that, I need the mean and the standard deviation because I'm going to be using the formula for the z-score. So let's see. The mean is the same as the population mean, same as the population proportion. So that's going to be 0.46. And sigma is, standard deviation is square root of the assumed proportion from the null hypothesis times 1 minus that over the sample size, and all of that under the square root. Okay, so if you do that again on a calculator, you'll get 0.014. So the p-value we're looking for, we're investigating the probability of the proportion not being equal to 0.441. And converting that to a z-score. So the z we want is 0.441 minus 0.46 over the standard deviation which we said was 0.014. Again, doing that on a calculator, you get negative 1.36. This is called the test statistic. This negative 1.36. Okay, so what are we looking for in the z table? Well, so there's the mean. Okay, so negative 1.36. So we're, in a sense, we're looking for the probability that z is not equal to negative 1.36, but it kind of doesn't make sense if we say it that way. So because why? Because the probability that z is equal to a particular number is 0. Remember, that's the kind of weird thing with continuous probability distributions. If you look at the area or the probability for any single number, it's 0. So what's the probability that z is not equal to negative 1.36? Well, it's 100%. It's 100% minus 0%, 1 minus 0, you get 1 or 100%. So we can't really think about it this way, and so that's why I've been kind of emphasizing saying when we talk about something being, say, greater than or less, equal to or not equal to a particular number, the way you want to think about that is how likely is it that z is not equal to negative 1.36? Think of it this way. How likely is it that z is this far off the mean or further? And since we're not necessarily interested in just greater than or just less than, but not equal to, we're interested in what's the area that's at least this extremely off the mean in either direction. Okay, so kind of to cut through all those words, the area we're interested in here, the total area of the shaded regions, is the p-value. And so again, it's when you have not equals in your alternate hypothesis, that's when you have this two-tailed test. So you're looking for area that's further away from the mean value, but in either direction. Not just to the left or just to the right, because we're not just interested in less than or just than or in just greater than. Okay, so with all of that said, let's find out what that area is. Oh, and by the way, it's the same area on both sides. So this p-value the p-value for this hypothesis test is the probability that z is less than negative 1.36 plus the probability that z is greater than positive 1.36, those two areas out on the ends. And we can compute that by just doubling one of the areas. So I'm going to use the table to get the area to the left of negative 1.36 and then multiply it by 2. So looking at the table, negative 1 for the z's, for the standard normal, negative 1.36, let's see, negative 1.3 out to 6, and it looks like we get 0.0869. And we're multiplying that by 2. So we'll get 0.1738. Okay, that's our p-value. Now, remember what we need to do with that p-value is compare it to the level of significance. Our level of significance was 0.1. Okay, so that's our alpha. So if the p-value is greater than alpha, we are going to say that we do not reject the null hypothesis. So if the p-value is greater than the level of significance, you do not reject. So our conclusion is that there is not sufficient evidence Now remember, even though our decision is whether or not to reject H naught, our conclusion is going to talk about H1, the alternate hypothesis. So we're going to say there is not sufficient evidence, and we need to say at the alpha equals 0.1 level of significance, because otherwise it's not clear what sufficient means. Okay, so there's not sufficient evidence at the alpha equals 0.1 level of significance to conclude that Americans with bachelor's degrees feel differently than the general American population regarding gun control. Feel differently than the general American population regarding gun control. So our findings did not make H naught unlikely enough to be rejected. Okay, so that's a two-tailed test. So the whole hypothesis testing procedure is the same as for the one-tailed test. It's just that you have to know that you're looking for areas that are outside your z values, both on the left and the right. So I'm leaving you here now with a very similar example. It's a two-tailed test again. So in 1994, 52% of parents with children in high school felt that high school students were not being taught enough math and science. A recent survey found that 256 out of 800 parents with children in high school felt that high school students were not being taught enough math and science. Do parents feel differently today than they did in 1994? Use the alpha equals 0.05 level of significance, and you don't need to verify the requirements of the hypothesis test. Okay, so I'll see you in the next example to go over this problem with you.